Hello everybody, good morning to all of you. This is Nikhil and I will be explaining you the apparent weight of an object in a lift. Yes, you have heard it right. This is the apparent weight. It means what? That if you are standing on the earth, you will be having your real weight. Now what actually is the weight? The weight is the force of the gravity by the earth which is being exerted on the body. Okay, fine. So we can say that if you are standing on the earth, on land or somewhere on this support, right? So you will be having your weight acting in the downward direction. Yes, the weight will always be acting in the vertically downward direction. Please note this point that it will be always acting. It will be always. It will be always acting in vertically downward direction. Yes, always. It will be always acting in the vertically downward direction. Now you will say, sir, why are you always going to stress at this line that will be always acting in the vertically downward direction? See, if you are standing on an inclined plane like this, okay, yeah, if an object is kept on this one, many will think that the mg it will be acting like this. Many will think that in the vertically downward. No, it's not like that. It will be always acting in the downward direction, but in a vertical direction. Means in a pure vertical direction. Means it will be acting like this. Okay. So for your myth, if you want to get it clear, I can explain you that it should act like this mg. And many people used to draw it like this mg. That is wrong. It is wrong. Okay, so it will be always acting in the vertically downward direction. Now see. Okay, so suppose you are going in a lift. Okay, suppose you are going in a lift, and if I ask you what's your weight, you will be very happy and you will say that, sir, my weight is 45 kg, my weight is 55 kg, I am very healthy, my weight is 60. Very good. You know what? If you go in a lift which is moving with some acceleration, yes, which is moving with some acceleration either in the upward direction or in the downward, your weight will going to get varied. You will ask, sir, how this is possible? I've got the same bones, I've got the same mass, I've got same everything. And if I go inside the lift, then how does it vary? Okay, so we see that the weight measured by a weighing scale. The weight measured by a weighing scale, okay, is actually the normal reaction. Yes, this is actually the normal reaction exerted by the surface on the body. Exerted by the surface on the body. Very nice. Okay, it is actually the normal reaction being exerted by the surface on the body on which it is kept. Fine. Now see. Okay, done. So now let us see a lift out here. Lift. And you are standing on the lift, and this is the weighing scale. Okay, this is your weighing scale. Okay, and suppose it is going upward with an acceleration a. Suppose it is going with an acceleration a. If I draw the free body diagram of it all, your weight will be acting downward, that is your mg, and there will be a normal reaction n. Okay, this is the first case in which we see that the lift is going upward with an acceleration a. Now, in the second case, it may happen that the body is, or the lift is moving downward with an acceleration a. Okay, with an acceleration a, this is your weight acting on it, that is your mg, and this is your normal reaction. Okay, right? In the third case, we can say that suppose I have got some rivalry with you, and you are going upward or downward in a lift, right? I may cut the rope out here. So यहाँ पे rope आपकी होगी, I may cut that rope, right? And you will be freely falling down. In that case, we can have a third case out here that the lift is freely falling. Now you will say that, sir, the lift will be freely falling with an acceleration? Yes. Sir, A? No. Then what? What should be the value of the acceleration by which the body is being attracted towards the earth? It is constant if you are on the earth, means if you are not on the Mars, right? It will be having its own value, that is the g. So the acceleration is the acceleration due to gravity with which the body is going to fall down the earth, right? So here we are having the A which is equal to z. Okay, and the same case we are going to draw the free body diagram also, that is your mg and that is your n. Perfect. We are having the three cases in which we have to see that what happens to the weight, means what happens to the value of the normal reaction in the lift when it is going upward, downward, or freely falling in the downward direction. It's very obvious that it will freely fall in the downward direction only, right? There is one more thing. What happens if the body is going upward with a constant velocity, right? That is the fourth case. Okay, so we can draw the same case here also for this one. Okay, suppose we have got a weighting scale out here and you are standing like this one, and the body is moving upward, the left is moving upward with a constant velocity. With a constant velocity. Means dv by dt with the time will be 0, means the acceleration is 0. Yeah. Fine. It will be also having its own free body diagram. Say mg and say n. Okay. Now we have studied in the laws of motion what? That if a body is moving in one direction with an acceleration a, it means that the net force acting on the body in that direction is more. Say, suppose if you take a very small example of it one. Say, suppose here is the body of the mass m, and here is the force F1, and here is the force F2. And if I say that F1 is more than F2, okay, so you will be asking that what is the net force acting on it one? The net force acting on the body is F1 minus F2. Right? Okay. Now, so now we have got the net force. Now what? Now what? Now what means the force, the direction in which the force is more, the body will move in that direction. Okay. But with what acceleration? That is the case. So if we say that F1 minus F2 is the F net, right? So the F net is the net force, net external force, mind my words, net external force acting on the body, that will make the body of the mass m to move with an acceleration a. Let it be ma. So the a will be what? F net by m. Yes. Okay. So we see that the body will move in the direction in which the force is more. Now we will use the same thing out here in all four situations. Okay. So now we come to the first one. That is, the lift is moving upward with an acceleration a. Okay. So now in that case, should I rub this part, right? Okay, fine. Okay, fine. So now we see that here n is more than mg. Sir, why? Because the movement of the lift is in the direction of the n. Here we are having the two forces n and mg, right? So what is the net force acting on it? That is your n minus mg. Okay. And with what acceleration it is moving, means what is the net force acting on it? Let it be some F net. Okay. What actually is that F net? N minus mg equal to ma. Okay. And your n will become mg plus ma. Here, what your weight would be n is equal to mg, but it has got increased by a factor ma. Yes, your weight was n is equal to mg, but it has got increased by a factor ma. So we can say that as the weighing scale is used to measure the normal reaction, in that case the weight of the body seems to be increased, because it's all about the game of the normal reaction, and that has got increased when the lift is going upward with an acceleration a. Okay, now we come to this part. When the lift is going downward with an acceleration a. Okay, fine. So I can write it for here like this. Okay, this one is here. Here you see that mg is more than n. So why? Because the body is moving in the direction of the mg. Okay, so means that the net force acting on the body is in the downward direction. So that is your mg minus n. Okay, sir, but what is the net force acting on it one? That is your ma. Okay, so now if you have to find out the value of the normal reaction, that will be your mg minus ma, that will be n. So we see out here is this equation that mg has got decreased by a factor ma, and hence the value of the normal reaction, that would be n is equal to mg, had got decreased, and hence the weight shown on the weighing scale will get decreased. And you will say, oh my god, I was 45, now it is showing 35. That's all the value of the acceleration. It does totally depend on the value of the acceleration. Okay, fine. Now here, what happens? This is the case in which the body is weightless, freely falling. A body, it can be of an elephant also, of a dog also, of yours also, of anyone's. No matter what, if the body is weightless and is falling freely, their normal reaction exerted on it will be zero. Hence the weight which could be measured, which will be measured by the weighing scale will be zero. See how? Here we will follow the same thing. mg minus n, right? Why? Because mg is acting in the downward direction and n is acting in the upward direction. So mg will be more than n because the body is falling freely down. Let it be equal to ma. That is the net force acting on it, right? So if you want to find out the value of the n, mg minus ma, that will be your n. So an a is what? G. Sir, why? Because the body is moving downward, is freely falling downward with an acceleration due to gravity. So the a will become g. So n will become 0. And this is the weight measured by the weighing scale, which is 0. Okay. Okay, fine. Now we come to the fourth case. With a constant velocity, a will become 0. Yes. Why? The rate of change of velocity with respect to time is the acceleration, and if there is no change in the rate of the velocity, the rate of change of velocity is 0, means the acceleration is 0. Okay. So in that case, we can say that it will be either moving upward or downward with a constant velocity. So it will be having n is equal to mg itself. Yes, you will be having the same weight out here. Yes, you will be having the same weight out here. That's all. So I hope that it might have cleared your doubts regarding how the weight is going to vary in the lift which is going upward, downward, or freely falling or moving with a constant velocity. Thank you all. Thank you very much.